Attendees are in listen-only mode.
Good morning, everyone, and thank you for attending today's webcast, Getting Started with Autodesk Inventor HSM Express. Our presenter today is Matthew Nichols. He's a solutions engineer with Hagerman & Company. We're also joined on the line by Tad Whitchurch. He's the director of CAD/CAM training support for Hagerman & Company. Before we get started, I want to let you know that you're in listening only mode. If you have questions during the presentation, just type them into the question panel on the right-hand side of your screen, and Tad will address them as we go, and Matt can handle some at the end of the webcast. As you exit the webcast today, you'll be prompted to fill out a survey, and we ask that you take a few moments to fill that out. And with that, I'll hand things over to Matt.
Thank you, Ashley. Thank you, everyone, for joining today. Basically, today what we're going to look at is how you can get a kickstart into using the HSM Express product. So with that, the kind of topics we're going to cover today is job setups, how you can work with them, covering tool libraries, being able to create your own tools, and even establishing network libraries so that multiple users inside your company can use them. Toolpaths, what's covered in the 5 tabs, and ways that you can control areas that the toolpath is actually being generated in. Then we'll look at simulation and posting code. So with that, let's go ahead and jump in and start taking a look at a part. So here we've got just a basic part. We've got some pockets, holes, so a basic 2.5 axis milling part. So what we're going to start off with is just creating the setup to start the program. So now with this, whenever you start, you're going to establish your work coordinate system, and an engineer may not always pay attention to how they're modeling the part. So your work coordinate might be off. Here I've got it modeled where my Z is already in the vertical, but it could be off in a different angle. So let's just say, for instance, it was this way. So one of the great things in HSM is it's really easy to be able to reorient your work coordinate. If you notice, whenever I highlight over the shafts or the arrows, if I highlight over the shaft, this I can actually pick on, and I want to pick a plane that I want that axis perpendicular to, and then I can just pick that plane and it'll reorient. Now if you pick on the actual arrow side of it, it'll flip it the opposite direction. Okay. Now, so that's the work coordinate. Now, selecting the actual origin of it, there's a couple different ways I can do this. So as you can see, I can select by model origin. I can do a selected point within the part. So say I want my 0, 0 set to the center of that hole. I can pick that geometry and it'll automatically snap to center. Stock box, which is a generic selection, so I can actually select box points, or I can do model box points. So those will actually snap to the overall size of your model. So here I'm going to go back to stock box, click here, and then I'm going to define my model. Now, for setting up the stock, there's 2 options that you have in Express. There's fixed size and relative size box. So fixed size is basically as it is. You establish the X, Y, and Z, and then you can actually set model positioning through here. So I can define, for instance, let's say I had a 30-inch long stock, and I wanted to cut 2 of these out. What I could do is I could set my offset to -X, so that now if I wanted to, out of this, I could actually pattern all these toolpaths linearly to be able to cut 2 parts out at once. And reset that. So that's for the fixed size. Now, relative size is a little bit more to the point. It takes the overall size of what your model is, and it'll create offsets. So there's 3 options with relative size. You do no additional stock, You can do additional stock to sides, top, and bottom. So that's what this setup is, where you have 3 options. Or you can do add stock to all sides. So you can actually define your negative and positive offsets off of the 3 axes. Go to 1/4 inch here, and I'm going to do an 1/8 inch offset there. And then the last tab for the setup is your post-process tab. So here you can define your program name or number. If you want a comment to post out, you can do that as well in this section. And then with this machine work coordinate system, the offset defined 0 and 1 are actually both G54. And then if you do 2, it's 55 and so forth. Now, if you do multiple parts on like a pallet or whatever, and they're the same orientations, just spaced out evenly, or not even spaced out evenly, but just the same orientations and stuff, you can do this multiple offsets. And what it'll do is you define the actual number of parts that you're going to be milling, and then you can define the increment, and this increment is for your actual work offset. So if I do 2 here, that means I'm going to create a 54 and a 55 offset. Then I start with 1, so 54 and then 55. So that's just kind of the basics on creating the work offset, or the setup. So now let's go ahead with the setup. We can go ahead and start putting some toolpaths on here. So let's start with the facing operation. And then in here, this is going to give me a chance to start looking at our tool library. So with the tool library, it comes with quite a few sample tools and holders, both in inch and metric. But you do have the ability to create your own libraries. So whether you want to create them and store them within a part, as you can see here, I've got a couple of tools already in here, or if you want to create them inside your own library and be able to do this, you can do that as well. Now, with this, my libraries folder, it's actually a generic folder that was created on your C drive. Now, earlier I mentioned before we started doing the actual work in the product that you can create network folders, network tool libraries. So what I'm going to do in this white space, I can right click and I get add library folder. So if I go in here, instead of C drive, libraries and documents, I'm just going to create a new folder under here. There we go. So now that creates the folder, and I can go ahead and start creating libraries underneath here. Now, another great thing with our library, our tool library, is I have this all tools library that holds everything in it. So let's just find our face mill. So here we've got a couple of them, and if you actually scroll over to the side, you can see where it says where those tools are actually stored. So it reads everything from every model that's open, any library that you have, it sees all. So anyways, what I'm going to do is I'm going to go ahead and select this 50mm face, and I can actually copy and paste tools from folder to folder. Maybe. Actually hit copy. Oh, there it is. All right. So now I've started this folder. Now, the next thing I want to show on this one is you'll see this little asterisk. So here I can actually save that library. So now, if I was to go to another user's computer, I could pull that up. And if I've got this library folded paths into my tool library, I'll see this and see the tools. But anyways, let's go ahead and start. Took a 50mm face. Now, one thing that's typical through all of our toolpaths is there's always 5 tabs that you deal with when you're creating a toolpath. So obviously the first one that we look at is our tool. Here we can also modify feeds and speeds. If I go to my second tab, which is geometry, this will be where you select pockets, holes, overall contours that you want to mill to. The third tab is going to be my heights tab. So I just set bottom, top heights, feed, retract, clearance heights. Passes is the fourth tab. So this is strictly everything that deals with the actual cutting action of the tool. And then my linking tab, the fifth tab, is everything that deals with the non-cutting aspects of the toolpath. So all my lead-ins, transitions between cuts, and so forth are done through here. So let's go ahead and hit OK, see what we get on this tool. Okay. So pretty easy and straightforward on getting that. So with that, I'm going to go ahead and do a simulation and kind of see what we have. So in the simulation environment, we can do stocked to show stocked. You can see the toolpaths. So I can do show points. It'll show points along the toolpath as it goes, and I can actually click on those and move to that point. And then you can do different variations of how you want to show the tool. So I can show the holder or not. I can show the whole thing transparent. And then I can also show my stock as transparent if I wanted to. I'm going to on this one. I'm just going to hit play. Okay, and so as that's going, I can go to my info tab, and that's going to show me just the general information about the position of the tool, the operation, and then I get my machining time and everything in the statistics tab. Okay. Now, here's an example of, okay, so whenever I did this face one, I'm going to go back in here real quick and show a little bit of how you can change the, I guess, the overall area that you might be machining on this. Maybe not always you're going to machine the whole contour as you see here for a facing operation. But I've got the stock contour selection, and even though I don't have anything actually selected, it defaults to the boundary of my stock. Okay, so I'm going to do something real quick. I'm going to do a sketch on here, and I'm just going to throw in a rectangle. Okay. So now my face is already, the face operation is already X'd out, saying, hey, something's changed in my geometry. I'm going to edit, and I'm going to select this contour as my actual contour boundary. Now, in the Passes tab, I said that there's everything that goes in the Passes tab deals with actual cutting action. So what we had seen before was that the link or the tool was cutting along the X and then transitioning across the Y for the different passes. But since I'm doing this right here, I don't want to come in on the X. I would rather come in along the Y and cut that direction. Okay. So what I'm going to do here on my passes, I'm going to do a 90-degree cut direction, and I'm actually going to give it an extension of, say, ½ an inch. Okay. So with that, now I'm going to do this, and now you can see my direction of the cut has changed, and I'm staying within that contour boundary. So let's do a quick simulation on this. Okay, so it's kind of a quick and easy way that you can see how you can control the boundary in which you're machining, especially with a facing operation. And there's other ways, if you're not doing a face like this, maybe you've got a welded frame angle that you put in the mill and you're wanting to kind of face off the top. You could do, with that model, you can just do the same kind of aspect what I did, but instead of doing a facing operation, you can actually do a trace. I'm not going to go showing that now, but with tracing, it will, let's do this, using the same facing operation. If I select that contour for the trace, it's going to do the center of the tool along that contour the whole time. So I'm going to do this, and I'm just going to simulate this real quick. So this would be one way, if you're wanting to reduce the amount of air cutting that might be happening, depending on the type of part you're cutting, doing this tracing operation would be another route to go. All right, so enough with the facing. We're going to move on to kind of roughing out these pockets with our adaptive toolpaths. So I'm going to start with this 1/4 inch flat mill. Actually, I'm going to edit it real quick. I'll change to number 2, Carbide. So in here I've got the tool that's been made. I'm just going to modify the diameter of it real quick. I'm going to go to 3/8 flat. I'm going to change the length to 75. Okay. That'll work. I'm going to go ahead and select this tool. Now, with adaptive, what I can do is I can just come in and I can either select the bottom face of a pocket, I can select the contour of a pocket to be able to get my geometry for where I'm wanting to contain that toolpath in. Now, with that, my height tab, I won't have to mess with it at all. It'll automatically, as you can see, it sets it to whatever the bottom depth of each of those pockets are. So that's why you won't mess with this, because if these were at different depths, it'll automatically compensate for that. Now, these are only 1/4 inch deep pockets, so in theory, say I had a tool that could handle that, I could just rapid or helix down in and then just do one clean cut out of the whole thing and hog it all out. But let's say it was a different material or a different depth, and I wanted to activate for multiple depths. I would come in here and check this box, and then I could actually define what my step down is. Now, one thing I want to show, HSM is highly good at being able to change defaults, make new defaults to how you want it to be. So one of the things I want to show in here is this edit expression. And you'll see this a lot on like the multiple depths, the optimal load. All of them are driven by expressions that are basically driven by your tool that you select. So here I've got a math.min tool flute length 10 millimeters. So basically what it's doing is taking the tool flute length and 10 millimeters, and whichever one is the lesser of the two values, that's what it's going to say is the actual step down. So there's different ways you can change it. You can just enter in tool flute length minus whatever, and that'll be what the depth is. But that's kind of ways that you can do this. And all this, if you know JavaScript at all, that's what this expression is driven from. It's JavaScript programming. But anyways, so here I'm leaving stock to leave, 20 thousandths on both the floor and the walls. Go ahead and leave that. Now for the ramping, I have a few different options. I'm going to go ahead and do the helix because I don't have a pre-drill and I don't really want to plunge. So I'm going to do the helix ramping. Let's say I do a 5-degree helix ramp angle. I'll leave the rest of this the same. I'll wait for it to calculate a little bit. Okay. So here you can see that I had the multiple depths activated, so I've got 2 depth cuts, and then I'm helixing down. Now, with those toolpaths, you can also see a few different other things. If I right-click on this little file size icon, I can get this right-click menu, and there's a couple of different things I want to look at. Machining time. Here I can get an idea, without doing simulation or anything, what my actual machine time will be for that toolpath. And I can also change that by these 3 values up here. So depending on what my tool time, or my tool change time is, what my rapid feed rate is. Let's say I'm doing 200 inch per minute on a rapid, and I can scale what my feed rate is. So let's do 110. So as you can see, that automatically would update that machine time. Another one, if you don't want to go in and do the actual simulations all the time, you can do what's called View Toolpath. And so here I can actually see the XY moves, and I can arrow down through them, and it shows the tool going down through those different toolpaths. So that's just kind of a quick, easy way. If something doesn't look right, you can go through there and say, oh, hey, I want to change that, before you actually post out any code. All right, so we've got those pockets roughed out. So next what I want to do is I want to go in and create a 2D pocket that will be basically derived from this, from the selections and everything in here to make a finished pocket. So I'm going to right-click on my 2D adaptive, do a derived operation, 2D milling, 2D pocket. So the tool, all the geometry selections, everything came through. But what I want to do is I want to create a little bit smaller of a tool. So I'm going to duplicate this one, hit edit. So now I'm going to go down to a smaller tool, make sure I can get in all the radiuses, change my tool number. Good with that one. So again, geometry, everything's the same. The one thing I want to do is I want to turn off multiple depths, and I want to turn off my stock to leave, because I'm going down to a finished surface. And let that generate. Now, something that's been added actually pretty recently is this more spiral machining. That's actually kind of cool. So if you look at this, once it generates, you know, all the lines, it's kind of, I wouldn't say really symmetric, but they're straight line radial moves. So if we go in here and actually turn on and use more spiral machining, you can kind of see that they change a little bit. And again, it's kind of how you want to do the machining, but there's a couple different options in how you can do the actual finished passes on this. So all right, well, let's do this real quick. Let's do one more. I'm going to go ahead and drill out these holes real quick, and then we'll look at posting code. Do this. Okay, so I know those are 1/4 inch holes. I'm going to go into drills. Grab a 1/4 inch. Where's that? There it is. All right. So now I'm just going to select that hole. And I'm going to say select same diameter so it finds all the rest of them. And then I'm going to go ahead and I'm just going to do the drilling through and do the rapid in out. All right. Let's go ahead and post this out. See what we get. Okay, I'm going to use the standard Haas. Okay, so one thing I want to note on the post process, and I don't think a lot of people kind of recognize, over in this lower right corner, there's kind of a user property box that you can actually change these different values in here. So whenever it says built-in, these are properties that are literally built into every post, no matter what. But below the built-ins, these are properties that can actually be customized per your post processor needed. So like for example, home position, this one is the one that's unique to the Haas post processors. Optional stop is on them, preload, and then these are typically on all the other post processors. But then here you have use G0, use G187, G28, parametric feed, radius. So this use radius will define whether you're doing IJK moves or an actual R value on the circular, on like your G3s. If you do subroutines, you can have that option as well, and then writing the machine and the tools to your post as well. So let's do this. I'm just going to go ahead and hit OK. Okay. So here is what comes out of our program into the actual NC file. So with this, we could literally take this to a machine, to a Haas machine, and put it in and start running. So we've got program name, the actual all the tools that are used in the program, and then we've got each toolpath. In here. Now, this NC editor comes free with, the HSM Express, and this is actually a really, really powerful tool. So with this, I can edit the NC functions. So you'll see all these have in numbers. I can remove them. I can renumber them if I want. I can block skip sections if I wanted to. So say I wanted to take this whole spacing operation out, I can do block skip. I can add or remove spaces, everything. I can do macros in here if I want to. So say, since we don't actually write machine information, and that was something that you needed on a post, you could create a macro that whenever you insert it, you can type in the information that you need to for that machine, and it would actually prompt you. For the backplotting, this one's probably my favorite thing in here. Here you can actually simulate all the toolpaths as they are. So let's do this real quick. Take this, move block skips. Alright, so then I've got my facing, start at the front, and I can actually simulate through the toolpaths. If I want, I can pause it, make changes, and then keep going. Now, the file compare window is pretty cool. Let's do this. I'm going to suppress this one, repost this out using the same, except this time I'm going to call it 1002. Okay. So now it'll open up in here. Now, what I can do is I can compare the two files window to window, and you'll see that it actually highlights areas that are different. So here I've got the whole tracing routine in. Here I don't. So that's just some ways that you can verify, if anything was made changes at the controller, you take the file back and verify if there was any changes or not. And then you have your DNC transmission. Okay. So now let's look at a couple other things real quick. So here I've got some larger holes. let's say I'm going to go ahead and do a drilling option in here, and we're going to do some circular cuts and boring in here as well. All right, let's find a different drill. Let's go to 5/8 drill. We're going to pick the center hole, and even though they're not the same, like the actual 5/8 diameter, they're actually 3/4 inch. Since I've selected that size of a hole, I can still do the select same diameter, and it'll find all the rest of those as well. Now with this, you can kind of see that my actual cut is only recognizing this height, but I've still got material above it. So I'm going to hit auto merge. You can see that it goes up to the top of the part. Now I know I'm not going to have any collision with my tool on the part. Okay. Do a quick simulation of this. And what you can do if you don't want to sit through the whole thing is I can just fast forward straight to the end. And there you go. Now the one thing I notice is that my hole didn't go all the way through the bottom. And I kind of need to. So go back into my drilling. In my heights, I can do drill tip through bottom, and then I can give it an actual bottom offset. So let's just do a 1/4 inch offset down. And that automatically is defined as -Z. So you don't have to put an actual negative value in there at all. If I rotate around, you can kind of see now those holes go through the bottom clearly. Okay, so now what we're going to do is I'm going to come in and I'm going to do a circular option to this diameter, and I'm going to do another one that goes to this diameter. So circular. I'm going to go back up to the 3/8 flat mill that I have. Pick there. Now, again, I'm going to go into my passes, and I'm going to change what my actual roughing step down is, and I'm going to go to an 1/8 inch step down. And then it's the same as what we did with the drilling option. It recognizes holes. So what I want to do is I want to make sure that it realizes that it's got to go to model top. Because whenever we didn't make that change, it's still recognizing only this distance that it's needing to remove rather than from the bottom to the top of the part. So then you change, or you see all the step downs now with that one. Okay. And then I want to do all my leads to center. So now you can see it's going to lead to center, link in, out. Go ahead and hit OK on that, and then I'm going to do another simulation. Okay. So now you can see that we've got that bored out to that minor diameter of that hole. And now what we need to do is get that on the rest of them. So I can come back in here to my geometry, go in and select the rest of the holes, and have it done. Now another option, and this is where, you know, there's lots of ways that you can do one thing, which is, I think, good in my opinion. I can go into my drilling routine and 3/8 flat. Now if I go into the cycle types and pull this down, you'll notice I've got the option for circular pocket milling. So here I've got the same thing. I can define it to my diameter, which is 3/4 inch in here, and then I've got a step over, of what I want to do. So the one thing that makes this one different is I can pick this pocket, and it's the same as what I was doing with all the rest of them. So I can just select same diameter and it finds all the rest of them rather than me having to go and actually pick those holes. And then what you see is it only shows the one depth, but if I come in here, let's do this. Let it do its drill. It actually does all the circular moves. You just don't see that in the actual toolpath outside of the simulation, but you can see it in here. So that's another way that you can go about doing circular pocket milling. All right, let's see. Did that one just real quick. I'm going to throw a slot in here real quick. I'm going to show slot milling. I guess that wasn't the best location, was it? We'll just change that real quick. Oops. There we go. All right. So let's say we're wanting to do a slot mill on this. For one, I'm going to have to generate a different setup, but rather than going through the setup process again, I can right-click on this initial one I did and hit duplicate. Remove all the toolpaths. Edit. Flip my Z. So now it's on the top. And if I really want to, I can change my stock point. Okay. Now I'm ready to go in here. So now what I can do is on the slot mill, make sure my right folder is default. There we go. So now what I have to do in here is I just have to pick contour for the slot, and it'll basically do all the rest. So what it'll do is it'll zigzag in, do a finished pass at the bottom, and then pull out. So let's do a simulation on this. Cool. Then you got your perfect slot. So that's a lot of about it for the toolpath. 2D contour is pretty basic. You're just picking contours to follow around. Oh, one of the things with contours is you can actually control how it interacts with corners. So like right here. So if you notice, let's just hit OK. It showed roll around corners, so you can see it literally just rolls around it. If I go and edit that, pull it down, I can do keep sharp corners and then keep sharp corner with loop. So let's look at sharp corner with loop, or just sharp corner. So it literally goes out, goes back through. And then with loops, it will actually loop around to get a fresh start at it. So let's do this. Let's make this one. So a couple options on contours. Bore works the same as circular option. You get the same geometry selection, basically the same passing information. Thread. Yeah, so thread's going to be the same way. Let's go back over here. Default. Here I would have to have a threading tool, basically, but it's going to be the same concept again. Here you can tell it threading hand, and then you give the pitch and the diameter offset. You can tell it, so that'll give you the actual threading, and then you can tell it multiple passes, and you can actually give the number of passes that you want it to take with the step over. Or if you do multiple threads, you can define the number of threads that you actually want to create. And you can tell if they repeat passes or not. So if you wanted to come back and make sure that there wasn't any kind of, I mean, obviously in a part like this, you're not going to have any kind of deflection, but if you're doing like an external thread on something smaller, there might be some kind of deflection. So that would just be to make sure that you got that cleared off. And then again, passes is basically the same. Lead to center, and I can use helical leads as well. The last thing I'm going to show, if you do setup sheets at all, there's a couple different ways that we do setup sheets. You can do it through the XML route, or sorry, the HTML route, so it actually gives you this that you can print out. Or if you're more into the Excel side, you can go to the post-process routine, and I can actually go in here and select my setup sheet Excel. And then what this will do is launch Excel. So then with this one, you get 3 different tabs in the workbook. You get the overall or overview tab, just showing program name, comments, date, who created it, part size, stock dimensions, number of toolpaths, basic overall information of the setup. Gives you the list of the operations, how long it's going to take, and the basic information for it, and then tools. Now again, posts are completely customizable. Both these setup sheets are created through post processors, so these are completely customizable as well. We've actually done quite a few of the setup sheets, and they actually turn out really cool whenever you get them the way you want them to be. That's about it. I guess, any questions?
Hi, Matt. This is Tad. I think I've answered most of them, but we can leave the chat and wait for a few more if anything pops in.
Yeah, I can do that. right, so chamfering. Let's look at. Okay, I'll show the subroutines first. So the one that's, let's just do this one. Post process. Go back to my HOS. Generic. If I do use subroutines, now the one thing that's different is this one will put the subroutines inside the program. Some of the posts that we've created, you get the option of whether you want the subroutines in or external of the actual program, so it actually calls for a different program number. But let's go ahead and do this for 1003. So then what it's going to do in here is, slot comes, it rapids to the position, and then it calls the subprogram call. And then at the end of your program, then you get all the toolpaths for that subprogram or subroutine. For the inputting tools from outside sources, the way that I have typically done it, because I've been working on creating some Mitsubishi tool libraries, I actually have, so there's a way that you can do it. You can either create them individually inside of your tool library, or what I typically do is I'll create a few of them, export them out, and then you get like you can export them out to a TSV file, and then you can pull that into Excel, and that'll give you all the basic columns that you need to fill out for all the tools. And then you can just start adding rows of tools to it. Or I've actually created an Excel like a cheat template basically, where I give it the basic information, it fills out all the columns for me, so I can literally just fill out basic information, hit create tool, and it'll take all that information and put it in the appropriate columns on a separate sheet, and I can speed create tools that way. If there's solid models, you can actually do what's called a form mill. So let's show this real quick. So whenever you're creating a new tool, in the Cutter tab, if you pull down Types all the way at the bottom, there's this form mill option. And so here, as long as, I don't know how it does with like step or IGES files, but if it's an Inventor file, I can import it in as long as it's a part that consists of one revolution. Anything more than one revolved feature, it won't accept, but I can import it that way and then have it as a tool. Chamfer an edge by stepping your cutter in either X or Y together. Okay, for the chamfer, so there's a couple different ways that you can do that. Typically what I suggest is always to model the chamfer, but if you don't, let's do this 2D contour. Well, 2D contour, if I go and find an actual chamfer tool, chamfer, okay, so once I select the chamfer tool, I automatically get this chamfer section inside my passes. So here I can actually give a chamfer width, so your distance back, and then a tip offset of the distance down. So you can do a combination of this, but rather than doing that, if you just model the actual chamfer itself, so let's just do this. Okay. Go back to the CAM. Chamfer tool. once I have that chamfer done, I can select the lower chain of that, and it's automatically going to snap the lower section of that tool. So like this edge, it's going to snap that edge of that tool to that line. And so if you want if you want the tip offset down lower, the only thing you have to do is go into your passes tab, and I can give a tip offset. So let's say I want it 50 thousandths below that actual chain, or the geometry selection. I can hit OK and do that. And so that's going to give me that that offset down. So I don't have to change anything else. It'll already compensate for all the other moves. All I'm telling you is I want the tip offset down from that bottom edge, and it sees everything else. Use change lead-in location. Yeah, there's a couple different ways that you can change lead-in locations. Let's do this one. So if you go to linking, there's your lead-in, lead-outs in here. But there's also the option of positioning. So if I had a certain point off the side that I wanted this to enter, I would create like a work point basically at that position, and then I can say entry position, pick that point, and that's where it'll lead in from. If you don't want to do that, then you can modify the lead ins here. So you have your horizontal radius, the lead in sweep angle, so that's as you can see there, it's horizontally as well. A linear lead-in distance, and then your vertical lead-in radius. Now, once you set these, you also have the lead out here that's checked. So by checking this, and same as lead-in, it automatically defaults all lead out values to the same as your lead-in. Now, if you uncheck this, the lead or the same as lead-in, then you can fill in all the information for your lead out as well.
Again, just a reminder, if you have any questions, please use the questions pane on your GoToMeeting screen. We do have a few more minutes, and we can stay on the line to answer any questions that might pop up.
Height step, or changing defaults. Yeah. So there's a couple different ways you can change defaults real quick. If it's any kind of text value, you can actually change it within the toolpath, and so it'll change for any created 2D contour. So you can see here I've got make default, make all default. So that's how you can do that. Now if it comes to how the actual plane selection is done, like any of these pull-down menus, that's done through a different process. So what I can do is, if I do this compare and edit on the right-click menu, this gives you all the different basically parameters that go into that toolpath. So if I want to change how my retract, okay, so here's my retract height, offset, that value, and here's the retract height and the actual selection that's done. So I can change the selection in here, and once I get it to where I want, say that's how I want it standard no matter what, I can then right-click on that and say make all default as well. So then once you do that, anytime you create a 2D contour, no matter what, that's how it comes in. Yeah, so the default settings files are local. I don't remember where they are at exactly, but I know they're XML files. But that's something, so the way that it's stored, it's actually stored by this 2D contour name. So if you ever want to try to find it, you could do, in the Windows Explorer, you could just search for contour.xml, you know, with a wildcard in the front, and it'll find it for you. But I'm pretty sure it's in the app data location in the local.
Okay, if there are no more questions, this will conclude our broadcast. If you think of additional questions, you can simply reply to that confirmation email you received from GoToWebinar. We can get those to Matt and get your questions answered. Once again, if you could take a few moments to answer the short survey, we would appreciate it. It will automatically appear when you close down the session. Other than that, thanks, Matt, for presenting, and thank you for attending today's webcast, and have a great day. Bye, everybody.